All right, let's dive in. We're handing over more and more of our world to AI, which brings up a huge question. How do we actually know we can trust it? Today, we're going to talk about something called verifiable AI. It's a new kind of technology designed to build that trust and maybe even flip the script between you and the big AI companies. And it all starts with a simple question you've probably never even thought to ask. So just think about it for a second. All those AI services you use, the ones that help you code or generate images or write emails, when you type something in and hit go, what's really happening? How do you know for sure that the system on the other side is actually playing fair? Well, here's the thing. You don't. When you pay for a premium AI, you're basically just taking the company's word for it. You have no real way of knowing which model you're getting, if it's been messed with, or if they've quietly swapped it for something cheaper. The whole thing is a complete black box. And look, this isn't just some paranoid what-if scenario. This quote right here, it's from a real situation where developers using AI coding tools started to feel like something was off. The performance just wasn't there. And they began to suspect that they were secretly being switched to slower, less capable, and yeah, cheaper AI models to save the provider some cash. You see, this gets to the heart of the matter. It creates this massive trust problem. Because if we can't even verify something as basic as which model we're using, how on earth can we trust AI with the really important stuff? This is way bigger than just getting your money's worth. It's about building a solid foundation for a future that's clearly going to be run by these systems. So, what's the fix for this crisis of trust? Well, the solution is actually inspired by something you use dozens of times a day. You just probably don't think about it. People are calling it the SSL for AI. And the idea is actually pretty simple. Remember the early days of the internet? It was all HTTP, totally insecure. Then along came HTTPS and that little padlock icon in your browser. And that one change created this layer of trust that unlocked everything from online shopping to banking. Verifiable AI is designed to be that exact same padlock, but for artificial intelligence. At its core, it's all about this cryptographic receipt. Think of it like a bulletproof mathematical guarantee that you can check. It proves that the exact AI model you paid for ran exactly the way it was supposed to, using your specific data to get the result you see. No secret downgrades, no tampering, just cold, hard proof. Okay, but there's a huge catch. Trying to create one of these cryptographic proofs for a giant modern AI model, it is insanely difficult and expensive. To give you some perspective, just proving an old, outdated model like GPT-2 required a supercomputer. For the models we use today, it's basically impossible. This is where a really clever technique from a team called Disperse comes into play. They realized, hey, instead of trying to prove this one gigantic, impossible thing, what if we just slice it up? They figured out how to break the model into tons of small, simple pieces. And by doing that, they turned an impossible exponential problem into something that's actually manageable. And to make things even faster, they borrowed a trick from the world of video game graphics. You know, for these enormous calculations, like in computer vision, they use a method called tiling. It breaks one massive job into smaller tiles that can all be processed and proven at the exact same time, in parallel. And that makes it radically faster. Okay, so now you've sliced your enormous problem into thousands of tiny, bite-sized pieces. Great. Who's going to do all that work? This is where a decentralized network called BitTensor enters the picture, and it completely flips the economics of this whole thing on its head. By running all these little verification jobs on the BitTensor network, the cost just plummets. We are talking over 90% cheaper than if you try to build and run all the massive server farms yourself. I mean, that's not just a little bit better. That is an absolute game changer. So why is it so much cheaper? Well, it's because BitTensor creates this open competitive market. You have a global network of computers, they're called miners, all competing against each other to solve these proofs as fast as they can. And that ruthless competition is what drives down costs and forces crazy innovation in a way a single company never could. This quote right here is just a perfect example of that innovation. The Disperse team was just looking at their charts one day and saw their proof times suddenly got cut by more than half, from 10 seconds down to 4. Turns out their top miner, on his own, had designed and programmed a piece of custom hardware, an FPGA, which is like a specialized chip, just for this one task, just so he could be the fastest. That's the power of a decentralized network right there. So let's zoom out. What's the really big picture here? Why does all of this matter so much right now? It's because AI is finally moving out of the lab and into the most critical parts of our lives, where the stakes are incredibly, incredibly high. We're talking about self-driving cars that have to make split-second life-or-death decisions, humanoid robots walking around our homes, AI systems making medical diagnoses or running our financial markets. In these worlds, having an unforgeable receipt that proves an AI did what it was supposed to do, that's not just a nice feature. It is an absolute necessity for safety, for accountability, for liability. And that really brings us to the final and most crucial point. Because as AI makes more and more decisions that impact our money, our property, and even our lives, things are going to go wrong. It's inevitable. And when they do, verifiable AI gives us the cryptographic receipts we're going to need to answer what might just be the single most important question of the entire AI era. Who or what is to blame?